Okay, sand is pouring from a pipe at the rate of 16 cubic feet per second. Well, I like to highlight the numbers because then it's usually going to be relevant. It's not always relevant. Question? If the falling sand forms a conical pile on the ground whose altitude is always 1/4 the diameter, how fast is the altitude increasing? Well, that's okay. When the pile is 4 feet high. Okay. Now, do you understand what's happening here? When the sand falls, here's the original pile, but then what happens over time? What's changing on this? The radius is changing as well as the altitude. What is altitude? Yeah, but what is altitude? It's equal to the height. And given that my formula is right here, I would probably like to work with those variables. Adam, do you want to come up and sit up front? Okay. This is the radius. That's the height. Go ahead and try finding the find, given, and when. And we'll see. You need to label that. So I made this R, so we're all on the same page. And I made this H. I think I'm crooked. Okay, so go ahead and try it. Oh, you did already. Good. So what is that? You need a derivative in the two spots. Mm-hmm. Put numbers in, but not before.
No. 4H.
Going? I love it. What's tomorrow? Wednesday? No. We have a quiz tomorrow on this, but I think you'll get it before you leave. If you're absent. Some people aren't. If you're not ready, you're not ready. You won't take it then. Okay, so what's your find? Whoops, let me get the thing going. Never mind. What's find? I want to find how fast the altitude. So it's dH dt, right? What is it I'm given? 16 cubic feet per second. What is that? Cubic feet. Rate of what? It's the change in the volume, right? Think of that as delta V. It's okay, because that's what it is, except it's really little. And it's divided by what? Seconds is unit measurement of time. When the pile is 4 feet high, what's 4 feet each? So here's the secret to doing these problems, at least in my mind. I look at the diagram, but I look also here at V and H, and that's what I want to keep in my formula. I want to get rid of, no, R squared. That's my goal. Okay, now I'm going to take this statement right here. The altitude is always 1/4 the diameter. That's an equation. 1/4 of the diameter. What's the diameter? So H is equal to 1/4 of 2R, which simplifies to give you 1/2 of R. I want to get rid of R. H equals 1/2 of R, so what's R equal to? 2H. Is that okay? Substituting it into my formula, and like I gave it to you here, they will give you that formula on the exam. So V equals pi R squared H, oops, the cone, 1/3. So I'm going to go ahead and substitute in R and square it. What's R? It was 2H. Ask questions. Are we all here at least? What should you do with that? Should you take the derivative now? No. We always want to simplify because that looks messy, doesn't it? So V equals, and now this is not calculus, this is just algebra. And what is 2H quantity squared? 4H squared. Should I take the derivative now? No. We can do this. Okay, so I'm going to put all this 4/3 pi, that's just these factors, they're not terms, times H cubed. There it is. I got the volume equation. It's simple, relatively simple. Now what are we going to do? Take the derivative. No, don't substitute the values in, because if you do, you're going to get volume equal to a constant. And what's the change in the volume then? 0. So it's d dt. Do I have to take the derivative of 4/3 pi? No. Good. You remembered. We have to pull that out. We can just bring that derivative right through there. If you want to see an explanation of why I ignore 4/3 pi, look at the video from period 2, because I had to do that. Okay, so dv dt equals 4 pi over 3 times what? 3h squared times dh dt. Calculus is done. All I have to do is simplify that, put numbers in, and solve for whatever I'm looking for. What am I looking for? Oh, dH dt. And h is equal to 4. So what's dV dt? 16 equals 4 pi over, oh wait, what happens to 3's? Let's get rid of them. So it's 4 pi over 1. And it's h squared, so it's 4 squared times dH dt. This is algebra. This is not calculus. Or was the calculus? But you know what 4 squared is? It's 16. Can I divide both sides by square? All I did was cross out the 3's and put in the 4. H is 4. It tells me that in the problem. So I substitute that in. And what's going to happen when I divide by 16? That'll cancel. That'll cancel, give me 1. So 1 equals 4 pi times dH dt. So what's dH dt? 1 over 4 pi, which by coincidence happens to be the answer from yesterday's problem. Well, still poll again. Yeah. Only if they ask for units. So make sure that when you take the exam that you read the problem twice and say, oh, do I have to put units in on this? Jay, can you scroll up for me? Okay, we're going to take a little poll here. Oh. Okay, there you go. Should have gotten the poll, right? No? Yeah. Ooh, I get the answer? You won't say that after the next one, though. Now what I need is a way to see who said what, so that I could help you. True. So most people are feeling comfortable. 6 people are on the fence saying, okay, maybe I got it, maybe not. And 1 person's not comfortable at all. I know who that is. No, I know who that is. Why? Because there's absences. Okay. No? Okay, let's try the next one. This one's a little different. Now, first off, there's a typo here. That's 1 kilometer. Now, the problem with this is understanding what's going on. We are in a helicopter now, and we are up at Split Rock Lighthouse, which is not in the water, but we're going to pretend it's in the water. So this is my lighthouse. That's my sun, where the light is going around in a circle, and it's rotating. This is 1 kilometer offshore. It's rotating 2 revolutions per minute. Now, we are in the helicopter above. We're looking down. So what you see when you look down is, here's the shoreline, and this is, all of this is water over here. And this lighthouse is spinning. So it's spinning around, and when it sits at this position, the light's going to be over here. And then it's going to be here. And then it's going to be here. Have you ever seen any of those old war pictures or any of those prisoner escape movies where they have the fence here, the wire, and they show the light going down? It's a lighthouse. They didn't have a light. I couldn't do a lighthouse the way I wanted to because we are in the helicopter. We're looking down. So down here is the helicopter. You guys are the shoreline, and the light is sweeping down the shoreline. I don't want to go around a circle up and fall. Okay? And it goes out to sea, and it comes back, and it sweeps. You ever see those old movies? Those old war movies and the lights going down the fence? If you go back and watch even Hogan's Heroes or anything like that. You even know who Hogan's Heroes is. Oh, you should watch Hogan's Heroes. It's so funny. Hogan's Heroes. It was a TV show based on Stalag 17, actually, that movie. You can watch that movie, too. 13. Oh, well, I was close. Okay, so that's what's happening. Well, I got to get rid of this. So we're looking down, and we're going to draw our triangle this way. And I have to fix this again. This is 1 kilometer. And this is tricky because of what is happening here. Okay, it's rotating at 2 revolutions per minute. Let's put that in the given. I'm going to have to do something with that because I don't know what that is. It's a little harder than what's in the book. There's one in the book similar to it. How fast is the beam moving along the shoreline? So I'm going to take a snapshot looking down, and here's my triangle. My beam is going to hit the shoreline right here. What do you want to call this length? L? L? Okay. Whatever you'd like. And it says, how fast is the beam moving along the shoreline? And then this got a little wordy. When it passes the point a half kilometer from this point, the point opposite the lighthouse. So when this length here is a half a kilometer. So L is equal to a half. You have to read it. If you read it slowly, you'll see what it's doing. Okay. And what is it I want to find? Oh, how fast is the beam moving? So what do I want to find? The LDT. Okay. Except I don't know what that is. 2 revolutions per minute. Well, what's 1 revolution equal to in terms of radians? The whole circle. How many radians in a circle? 2 pi radians. Okay, so this is and I'm going to multiply by this unit multiplier. I'm going to multiply by 2 pi radians divided by revolutions, because since these are equal, that fraction is equal to 1. You've seen that in science? Yes? You should have seen it in science. So this is going to be, and I do it so that units cancel out, 2 pi radians over 1 revolution. Do you see how the revolutions are going to cancel? It's called dimensional analysis. I'm sure you've done this in science. So what does that equal to? 4 pi radians per minute. What is that the change of? Radians. It's the change in what? You're rotating around. What's changing? Let's change angle, right? So what do you call the angle? Theta. I'm going to win on that one. Theta. You could. And this is d theta what? dt. Radians. Sorry. I wanted to keep the radians there so you realize that's the change in the angle. Okay. And like I said before, this is what helps me figure out what relationship I need. That's why they're called related rates. I have to relate these two rates. I need a relationship between this length and that angle. And this is all I know. I'm not going to use Pythagorean's theorem because it has no angles in it. What relates sides with angles? Tangent. Trigonometry is the way to do it. I want tangent because I don't know anything about that side. I can't do sine or cosine because I know nothing about the hypotenuse. Actually, it can be done. It's just not very nice. So the tangent of theta equals what? L over 1. What are we going to do now? Now we're ready to go. Now we have to do calculus. Take the derivative. And with respect to what? Time. I don't like to use the primes because you forget about what it's with respect to. You know, if I'm just doing a standard derivative, fine. What's the derivative? Do you remember what the derivative of the tangent function is? Excellent. Secant squared of theta times the derivative of the inside function. Don't forget that. Because if you don't have it, you won't know what to do with your d theta dt then, right? Equals, and what's the derivative of L but with respect to t? dl dt. We slide it up. Secant squared of theta times d theta dt equals dl dt. I want to find dl dt, which is nice, because all I have to do is figure out what the secant squared of theta is. And some of you are going to say, well, I don't know what that is. Let's draw the triangle. Now, this is when I take the picture. This is always 1 kilometer. This is half a kilometer. I don't have to know theta, although you could find it. Because I gave you calculators. You could find theta. But I don't really care what theta is. I care what the secant is. What's the cosine of theta? It's 1 over the hypotenuse. So what's the secant? Hypotenuse over 1. So what do I have to find? Hypotenuse. So I'm going to do similar triangles. And instead of reducing it, I'm going to make it bigger because I don't like the 1/2. You can if you want. But so this, if I double this, it's 2. If I double that, that's 1. What's this side? Square root of 4 plus 1 is 5. Now, do I have to go back here and say this is the square root of 5 over 2? Because if the triangles are similar, then what's true about the secant of similar triangles? Same. So it's going to be the square root of 5 over 2. Let's go ahead and put that in there. By the way, the calculus is done. That was the calculus. And we're going to square it. What's d theta dt? Oh, it's 4 pi, right? 4 pi radians. That's why we do radians, because they're dimensionless per minute. And that's equal to dl dt. So what's that going to give us? Yeah. I just put the secant in right there. That's kind of cool. The secant of my angle is the hypotenuse over the leg, and we're going to square it. I didn't find the angle. It's equal to 5 fourths times 4 pi. You're ahead of me. That's great. dl dt. And what happens to the force? D theta dt is 4 pi. Remember, go back up to the givens. That was right here. We'll let you try the next one. Correct. So the force cancel. 5 pi equals dl dt. We're going to do a quick poll again. See how many people I've lost. Yeah, you're gonna try that. Oh, are we gonna vote on it too? Okay, that's what you felt before. I gotta stop it. Let's try it again. This is so nice. And we'll start the poll. See how you felt about that one. I get to vote too. That's not fair, is it? Ooh, not as good. You don't like the trig stuff, do you? No, I knew it would be harder. I knew it would be harder because of the you don't like the trig. How come you can do that? I don't like that. Okay. I'm going to stop the recording and give you a chance to try the next problem. Oh, are we going to take the vote on the cowboy right now? Okay. Well, that doesn't mean anything. I only get 2 choices. Because I chose A, B, C, D. Who's in the others? Can you change your answers? Oh yeah, you can. Okay, most people think it's a girl, right? Should we see? Oh, I don't want to. Mustache, yeah, it looks like that to me. That's why I'm taking C. Okay. By the way, there are the answers to the worksheet. And I'll read this and I'll let you work on it. A person standing on the cliff is watching a motorboat through a telescope as it approaches the shore directly below her. Him, whatever. If the telescope is 250 feet above the water level and the boat is approaching at 20 feet per second, at what rate is the angle of the telescope, read that carefully, changing when the boat is 250 feet from shore? So give it a try, and I'm going to put a poll out that asks you to submit your answer. Nope, not multiple choice. You just type in the answer. And there are 2 ways you can do it. One's as a decimal,